Okay. Noah, can you go click on the discussions? Good. Yeah, can you click on the 8.3.5 class activity? Good. Wonderful. Yeah. So this is a 5 stage. So just you join this the Lucid by just clicking on the switch account, then click on sign up, then just register. Yeah, click on continue. Yeah, it takes few seconds to load that whiteboard. So on Zoom, whatever whiteboard that we are using, it is same kind of whiteboard. So you can maximize it, Noah. Yeah, good. And you can maximize and you can minimize also. Okay, this is one. I just want to make sure that you are able to access it or not. Okay, so can we together, because in your exam also, this whiteboard will be available in midterm two to practice, to complete this pipelining. So let us have a small activity to habituate with this. Okay. So on the, go to this blank board and from bottom second on left side of this whiteboard, bottom second in the whiteboard. Yeah, click on that. Click on table. Yeah, good. Select the table. Wonderful. So, how many rows are there in the above table? One, two, three, four, 5 rows. And you select 8 columns. Okay, good. So, click on any area. Yeah, yes. So, table is created. So, now you just type the first row, first column, just type cycles. Good. In the second row, first column, just type that instruction, add instruction. Yeah, add R1, R2, R3. Good. Similarly, complete the remaining instructions in that. So once you complete those instructions, then we'll make this whiteboard full screen. Dalton, are you following? Good. Okay. Yeah, wonderful. Good job. Yeah, now make it full screen. No, the whiteboard. On whiteboard, you just do the full screen. Yes, good job. Yeah, that button only. Wonderful. So now just give the number of cycles, give the numbers in the cycle column, cycle row, first row, first row. Yeah, 1, 2, 3, 4, 5, 6, 7. And if you go to the bottom here, when you are on table, then the edit button, the second button from left. Yeah, click on that. So it will add one more column. It will start going adding as the number of cycles increase. Is that okay? Playing with that? Good. Okay. So now let's try to do this pipeline activity. This is very important. The same activity will be helpful for your assignment 3 and midterm 2 also. Good. Yeah. So in this, the instructions are given that in this pipeline execution, there is no structural hazard But for data hazard, we follow. Can you minimize this whiteboard? Yeah. Yes. So if you go to the instructions above, then it says execute the following instructions in five-stage pipeline, which we discussed. Second, assume there is no structural hazard. Third one is we assume that for data hazards, it is bypass and forward. That means the interstage buffer will be used for storing the result of ALU output. Okay. And then finally, we need to enter the number of cycles taken by completing these four instructions. Right? That makes sense, right? So now can you maximize Noah? Wonderful. Okay. So then let's start working on pipeline. Each column that represents the pipe, each stage that represents the cycle. So in the first cycle, what happens? The first instruction allowed inside the pipe, correct. So what is the first stage of the pipe? What is the first stage of the pipe? Instruction fetching, IF, correct? Good. Okay. So what is the second stage? Let me also join. Just give me 1 second time. Yeah, wonderful. So here, remember, first we need to fill the entries in the pipe in column wise. Please remember that one. So in the second stage, first instruction added into the is no, no, no. Also, because in the first cycle, instruction one is in the instruction fetching stage. So that instruction fetching stage is busy. That is filled with the first instruction. So here you don't, sorry. Okay. Second instruction will not allow inside in the first stage. In the second stage, first instruction moved to instruction decode stage. So instruction fetching stage become free. So the instruction fetching will be added here. So you just use these shortcuts, IF and ID. Or if you write the whole, that's also fine. Okay, that's also fine. Yeah, first space, yes, good. So now at the second stage in the pipe, there are two instructions are there. One is add instruction, second one is the subtraction instruction. So just recall yourself, the instruction decode stage means the R2 and R3 registers, the value are reading from these two registers at this instruction decode stage. Does that make sense? No? Good. Okay. And in the instruction fetching stage, the subtraction instruction is it's fetching from instruction memory, correct? So in the pipe, first stage and second stage are filled. At the third stage, this add instruction enters into which stage? The pipe. It moves to very good execution style. Right. Let me make it exe, the execution stage. Okay. That means here the ALU is performing the add operation, adding R2 plus R3, correct? So let me use this sticky. Okay. Yeah. Let me type here. So this execution that take this. Yeah. Yeah. Let me use this. So here in this, it is adding the ALU adding R2 plus R3, correct? So at the end of this, oh, sorry, let me use this. Oh no, something happening. Okay, let me use this. Yeah, from this stage, it's adding R2 plus R3. So at this point, the result is ready, right? After this execution, isn't it? So then this instruction, subtraction instruction, enters into which stage? Wonderful. So when it is entering into instruction decode stage, let me use a different color here. It requires this R1, right? So is this R1 is ready at this point? Because here the result not yet written in the R1 because subtraction is depending upon the depending upon the previous instruction. So at the third stage, third instruction, multiplication instruction will also entered into the pipe, allowed inside the pipe, correct? So in which stage it is allowed? Wonderful, very good. Yeah, appreciate, correct. Right, so now at stage 3, there are 3 instructions in the pipe, right? There are 3 instructions in the pipe. So at the fourth cycle, instruction 1, that is add instruction, that moves into which stage? Yeah, at the fourth stage, the add instruction moves into which stage here? Yeah, MEM. Just give that terminology, MEM. Wonderful, good. So subtraction instruction moves to good. Dalton, can you enter your entry? Wonderful, good job, good job. So for the second instruction, it requires R1. Is that R1 is ready to execute by ALU here? That is ready. Why? Because in the interstage buffer, this value is ready here. So from this interstage buffer, this value, okay, that will be, that can forward to, sorry, I can, let me use this, okay. So this, from this interstage buffer, oh, Yes, yeah. From this interstage buffer that can be used, that will be forwarded to this ALU here, right? From the interstage buffer. So that is bypass and forward. Is that make sense? Yeah, this is in instruction fetching. So in yeah, that's fine. So I hope it's clear, right? For second instruction, R1 value is forwarded. That is actually R2 plus R3 is forwarding, but it is not yet written in R1. So that is the bypass and forward solution. Does that make sense? Yeah. Good. Okay. Yeah. So at the fourth stage, all the four instructions are inside the pipe now. So now comes to the fifth stage. The first instruction, add instructions, enters into which stage? Add instruction enters into, yeah, Dalton. Can you fill that entry? Wonderful. Good, good. Yeah. Let me write, fill these cycles. Yeah. Then subtraction in instruction enters into which stage of the pipe? Very good. Yeah. And multiplication enters into which stage? Good. So it requires which value? R4. Is that R4 is ready at this time? Good. So can you forward? Can you connect that arrow? Use the arrow and from yes, good job. Yes, Noah, connect it. Use this. Good job, Dalton. Yeah, connect it. Wonderful. Appreciate. Yes. No, no, no. Yeah. Wonderful. Superb. Superb. Very good. And load instruction enter into the instruction decode state. Wonderful. So there is no structural hazard and there is no data hazard, correct? So data hazard occurs only because of execution stage. So we have to be a little bit careful about that. So can you make a sticky here, Dalton or Noah? Like R2 plus R3, can you make a sticky here? Good. Okay. And just update the value R4 plus R3. Yeah. Yes. And can you connect the arrow for understanding? Yeah, that's good. Appreciate. Very good. Yeah. So now let's look at into the sixth stage. So at the fifth stage, the add operation is completed, right? Correct. Yeah. So at the sixth stage, which instruction will move into the next stage in the pipe? Here it is completed, right? So at the sixth stage, very good, good job. And yeah, That enters into memory access. Very good. And the next one is load instruction enters into ALU. Yeah. Can you have a sticky? What will be the output of this ALU? The load instruction ALU, last row ALU. What's the output of XZ? It's yeah. That's correct. Go ahead. Because ALU computes the effective address, right? R2 plus 10. Wonderful. That's the effective address. Super, super. Good. So then at the seventh cycle, in the sixth cycle, second instruction also computed subtraction. So in the seventh cycle, wonderful. Memory access. Good job. Good job. Very good. Okay. And then in the next eighth stage, in the eighth cycle, which instruction will be there in the pipe? Super. Appreciate, right? So now these four instructions executed in the five-stage pipe, in how many cycles? Can you type somewhere outside? Select the text box. Yeah, 8 cycles. Select the text box T on whiteboard. Yeah, just type. Very good. Right, wonderful. So in your assignment, you have to complete this activity this way. And in your exam, this activity will be designed like fill in the blank. So you need to enter this final cycle number. Is this clear? You need to enter this final cycle. So for that, this whiteboard will be available on Canvas. So you can complete and then write the total number of cycle. Is this makes easy or difficult? Please let me know. Dalton and Noah. It's easy? Good. Dalton, Noah. Super, super. Okay. Wonderful. Appreciate. Good. So this is the let me go to this. Yeah, this is the first